Good morning, and welcome back to Redacted Voices, a channel that gives you a bird's eye view into industrial repairs and installations. Today we're in the presence of a 1.2 million BTU batch oven, and the client called and said that they aren't getting any functions on the burner. So they want us to have a look at it and see what we can figure out. So here we are at the control panel, and the first thing that we're going to want to do is go ahead and cycle the control power on. And we're going to want to see what they see as we start up this oven. So you'll notice that there's many functions that need to read out before this oven can run. It's also considered the sequence of events. So for the moment, I could tell that the control power is on, oven temperature controller is on, but I'm not reading a control power illumination light or an indicator light. So we're going to go ahead and check that out throughout the troubleshooting process and see what's wrong, see what's going on with that. If I take this little cover off, yeah, that little lamp looks like it's out. So we'll go ahead and get that swapped out, see if we have a lamp for that. If not, we'll get one. So next part of the process is I'm going to go ahead and try to start the oven and cycle it on, and we'll see what we can see. So as I start the motors and the blowers, it's basically 2 circulation fans and 1 exhaust fan. Each blower produces an airflow. So we have sensor switches up there all over this oven that read airflow. And if the sensor switches aren't reading any airflow, then you won't get your Safeguard MET lamp. And I'm noticing right now that our Safeguard MET lamp is not illuminated. So something's going on, or this bulb is bad. So we're going to go ahead and do a real quick check to make sure that this bulb isn't bad, and we'll see if we're getting voltage to the contact inside this control panel and verify that this bulb is getting the needed voltage to illuminate the lamp. So here we are inside the control panel, and the first thing we're going to want to do is check that power on switch. I want to see if that little lamp is bad or if it's good and we're just not getting any power to that power on switch, and see if that could be one of our issues. So I'm going to go ahead and set this to voltage AC because that's what these switches are operating on, and it says it right at the top of the indicator lamp that it's voltage AC. So let's see what it reads. So the actual terminal block is reading 120 volts, which there's a hot and a neutral wire. So it is a 120 volt circuit. I'm almost positive that the lamp is bad. So let's pull this terminal out of there and see if we can't get that lamp changed. So the next step is we're going to go ahead and test our Safeguard's MET lamp, the other lamp that wasn't lighting. So the first thing I'm going to do is I'm going to want to verify that there's either voltage or there isn't voltage, and it's the same style circuit from the same voltage, 120 volts. So on that circuit, I'm not reading any voltage. So that's telling me that the Safeguard's lamp is not receiving voltage because the safeguards are not met. So we're going to have to go ahead and figure this out. So here we are back at the control panel, the front end of the control panel, and I want to go ahead and verify that our control power lamp is illuminated now. So we have indication that our control power is on, so that's good. So the next step is we're going to go ahead and start our blowers again and verify that our safeguards are either met or not met. So with all 3 fans on, our Safeguard illumination lamp should be lit, but for some reason it's not lit. So we're going to have to figure that out. So I'm going to go to the back of it and verify that it has voltage, 120 volt, since it's off the 120 volt circuit, and we'll see if we're going to get a reading or not. So according to my meter, there is no voltage there. So our safeguards are not met. So we're going to have to get deep into this oven and figure out why these safeguards are met. The best way to do that is by going to the schematic and seeing what's in line to get this safeguards met illumination lamp lit. So here we are at the schematic, and looking at the schematic on my 120 volt circuit, I can see my safeguards met lamp right here. This is a lamp that's not illuminating. So let's see what's in line in order to get this lamp lit. So the first part of this process is we're going to go ahead and check the airflow fan circulation switch number 1, 2, and 3. So I got to locate those on the oven and see if they're closed or open. I'm up here on the oven and I'm looking at the 2 circulation fan motors, number 1 and number 2, and I'm also looking at the safety switches, and it looks like one of them is not illuminated. So we're going to go ahead and see if it's just a failed lamp or if the circuit is actually closed. So I'm going to go ahead and reach in, and I'm going to put one terminal to the common, and I'm going to put one terminal to the ground, and I should be reading a voltage of 120 volt. So yes, looking at my meter, I am getting a reading of 120 volt. So now I'm going to go ahead and move to the normally open terminal to see if this switch is actually closed under operation. And yes, this switch is closed. So I am reading through voltage, so the switch is closed contact right now. So that means that this switch is reading air, and it is consistently and solidly closed. So this switch is testing out good, even though our indicator light isn't indicating. So I can see that that indicator light is lit. I can see that this indicator light wants to stay lit, but I think it's a bad diode inside. So that we're not really going to worry about that today or right now at this moment. I'll take a note of that, and we'll come back and we'll order a new switch or a new lamp, because the switch is actually good. It's just the indicator lamp that's bad. So now that we put our terminal cover back on, and we know that both switches are activated and reading airflow, the next switch that we'll move on to is our exhaust fan blower switch, which should be indicating, but I also noticed that the indicator lamp is not on at the moment. So we'll go ahead and open that up and see what that's reading. So again, we're reading 120 volts because this is off the 120 volt circuit. So I want my meter to read 120 volts off our common terminal, and then 120 volts off of our normally open terminal. And if we don't get 120 volts on both terminals, then we have a problem here in the air switch. So there, on my common terminal, we have 120 volts. Now let me check my closed terminal, my normally open terminal. So on both terminals, we're reading 120 volts. So that tells me that this switch is closing the circuit. Now let's see if we have 120 volts when I take the air hose off and see if the circuit isn't stuck closed. There we go. So on one side, our common, we're reading 120 volts, and on the other side, which is our normally closed switch, we have dropped off in voltage entirely. So this switch is operating as indicated. It's just an indicator light that is not turning on. So the diode must have went bad inside this indicator light, so we're going to have to get that changed out. So we have two indicator lights that we're going to request to change, and if the customer wants to do that, then we'll go ahead and move forward with that later on. So here we are at the gas low pressure switch and at the gas high pressure switch. So we're going to go ahead and check these for closed circuits to see if we're operating as indicated or as needed for this oven. So I'm going to go from common to ground, and I want to verify that we have 120 volts from common to ground, and then I'm going to go to my normally open and verify that our switch is closed. So these switches are operating as normal. So now we have gone through the entire safety circuit that would tell us either our safeguards aren't met or are met. So there's something else going on here, and we need to figure that out. So from where we started, we checked our circulation airflow switch number 1. We verified that that is closed and that airflow is present. We also checked our circulation airflow switch number 2, and that also checked out good. We also tested our exhaust fan airflow switch, and that tested out good as well. And then we moved on to our low pressure gas switch and our high pressure gas switch. So this whole series of switches, our safety circuit for our combustion burner to turn on or to give us an indication that our safeguards are met, is proven accurate. So everything is functioning as normal here. So we're going to go ahead and move on to what would activate our 1 control relay, 2 control relay, 3 control relay, and 3 CR coil. So we're going to go ahead and see what we can see, and it's indicating to me to follow to line 224 on this schematic. So as I was looking at the schematic a little bit deeper, I was troubleshooting through my control relays to see if I could get what's in series in order to get my safeguard met. And I noticed that we have 1 CR, which is control relay 1, terminals 12 and terminal 6. But terminals 12 and terminal 6 will never close until 1 CR is activated. So I had to find out what is in our pathway to get 1 CR activated. So then I moved up here to line 202, and I noticed that we have an excess temperature controller. So this is another temperature controller that is in series, and it'll hold out our control relays from being activated. And here we go, 1CR. So this is the coil for 1CR, and this over temp has to control this coil for 1CR. Now, in order for this over temp to operate, a regular temperature controller, which is on the next page, would have to be in a ready to run state in order for it to control and open and close all the relays that need to be activated. So right now at the moment it looks like according to the schematic, it looks like we're on a lockout. So we're gonna go ahead and test this theory and see if I'm right or if I'm wrong. This is what I'm thinking right now, just looking at the schematics. So we've already ran through all of our safety switches and we verified that everything is operational, which leads us to this point right here, and we can't move past this until we verify that the coil is activated and this switch would be closed, and that should light our safeguards met and tell us that we're ready to move forward with the sequence of operation. So we have to figure out why this one is not activated, and I believe it has to do with our primary temperature controller. So we're gonna go ahead and take a look at that first, because there might be something going on with that from what I'm looking at in the schematic. These are the controls that control our safeguards met. So here we are back at the front of the control panel, and here's our control power indicator lamp, the one that we changed earlier. So that's operational. Now we're gonna get our safeguards met. So as I was looking at this control temperature controller, I noticed that we're running in program. So we're actually in a program right now at the moment, running and operational. And when I got to this oven, it was already in program. So I believe we need to take it out of program and start all the operations from the beginning and then see where we're at. This temperature controller controls the inner temperature controller, which is just a high limit kick out. So if anything got too hot inside the oven, this would read a high limit and it would kick it out. So this is the 1CR coil that we need to get activated in order to get our safeguards met. So let's go ahead and start there. So I'm going to pull this temperature controller out of program and go ahead and reset from the beginning. We'll turn our blowers off, and then we'll go ahead and turn our burner off. I don't know why that was on. And then we'll go ahead and restart everything from the beginning. And just like the schematic showed, our 1CR is now activated. So it was due to a kick out because our temperature controller was running in program. So that tells me that somewhere along the line, somebody got the sequence of events wrong and tried to start this thing out of order, and that's what kept them from actually moving forward with turning on the oven and getting the combustion burner running. And yes, as indicated, our burner is on. So this is a good sign. So we'll go ahead and start to see from here if our oven is actually heating up based on the temperature controller. So it looks like our flame and our temperature inside the oven is raising. So this brings us to an end on troubleshooting this 1.2 million BTU batch oven. It looks like somebody tried to operate the oven without starting from the beginning of the sequence of operation. So if you like this kind of content and troubleshooting and repair and installation videos, then I suggest subscribing, and please leave a like at the end of this video. Thank you, I appreciate it.